Okay, we're going to start out by putting in a bunch of fields that we're going to be using throughout this episode. I'll explain them as I go. First up, we want a serialized field. This one is a layer mask. And we're just going to call this one Walkable Mask. We'll set the default value to 0. Now we want to actually grab another one of these. Call this one Collidable Mask. And set the value to 0 as well. Now we want a third serialized field. This one is a float for max fall cast distance. We want to set that to, well, I'm just going to set it to 100. This is going to be used for when you walk over an edge. How far down is the game going to look to see if you can fall down to another thing. Now 100 is pretty high. Probably not going to have distances that high in a game of this type, but it's just a value you can set to whatever you want. Next up, we're going to have another field. This one is another serialized field. It's a float and it's fall speed, and I'm going to set mine to 30. This is going to be the speed at which the player falls, obviously. I'm going to set mine to about 30. Default gravity is about 9.8 units per second, but that looks really slow. If you've ever looked at anything about video game gravity, it's always much heavier, unless it's a physics simulation, I guess. Next up, I'm going to put in another two things to do with falling. One is just a flag falling. It's similar to the moving one we have above. And then we have another float. This is the target fall height. That's going to be when we walk over an edge and we scan down and we see there's something we can fall onto. What's the height of that platform that we can fall onto? Okay, next up, inside the update function, we want to move to this section when we have the if moving floors, and then before it, I'm going to add if falling. And we're going to transfer this into an else if. So falling takes precedence. And the code inside this is actually very, very similar. So I'm just going to grab this, paste it up here. Now, rather than checking the distance from start position to transform, we want to do something a bit different. We want to check the transform position Y, and if it's less than or equal to the target fall height, that means we've fallen down far enough that we can safely assume we've reached the floor. So for these, we're just going to put transform position. There we go. And then for this one, we're actually going to put the target fall height here. So we're just rounding those off just to make sure that everything looks smooth, and then we set falling to false. Return. Now this is slightly different. Rather than going towards the target position, we want to go down. We want to go down at a rate of fall speed times time.delta time. There we go. Okay, here we are after the if statement that checks if we're falling or moving. We want to add an else to the end of this. This one is going to be the way that we can check if we're falling. So we're going to use something we haven't used yet. We're going to use raycast hit. And that's going to return us all of the objects that the raycast actually hits, and then we can test against them, find which one is the closest, and then also set the falling to true if it is a walkable object. So we're just going to move the ray up half a unit, because if you remember how our players created, the transform position is actually at the bottom of the player. So if we shoot a ray directly down from the bottom of the player, it's not going to hit the ground that it's already standing on, which means it'll just go through the floor, which is not what we want. So this is where the max fall cast distance comes in. You could just put a number in here, a magic number, 120, whatever. Not really a big deal. And this is where we use our mask for the first time. So the walkable mask, which we haven't set up in the editor yet, but we will shortly. That's going to be containing all of the ground and anything else you can walk on. Okay, so that's it for the raycast. Now we want to put in just a check to see if we hit anything. And if we did, we're going to go through all of the things that we hit and find the closest one. So this is only going to match anything in the walkable mask, which means it's only going to be something that we want to be able to fall on top of. So for this, we're going to just use a loop, and we're going to go through all of them. We're going to check the distance, and then we'll just update this top collider to the shortest distance. I missed a parentheses there. Okay. So the collider has something called bounds max y, which is the top of the box, basically, the top of the collider box. And we want to check if that is lower down than the current one. And if it is, then we want to set the new one because it's further up. That's pretty simple. Now we want to make sure that the distance is at least more than 1 unit away, because otherwise we'll probably be falling onto the floor that we're already standing on, which is not what we want. We set the target fall height here to the transform position y minus top collider distance, and we want to add that 0.5 back on, because if you remember, we moved our ray up 0.5 and we set falling to true. Okay, now there's one more part in here. What we're going to want to do is say if we didn't hit anything, then we're probably over a gap or a pit of some kind that just goes forever. So we want to set the target fall height to minus infinity, which means the player will just fall infinitely. Set falling to true. Okay, that's actually enough to get started. Let's pop over to Unity and have a look, see how that's working. Now I've put a bunch of objects into the scene, which weren't here before, and I'll just explain what they are. These red cubes, they are untagged, they're on the default layer, which means they're not walkable. And these, all the grey areas are ground, and ground, well, I call it ground, but it should be called walkable, either way. All of the grey things are walkable, and I've just named everything over here in the inspector to make it a little bit easier to see what's going on. So if you want to add a new layer, you can come up here, click add layer, and then just add a new layer here. We already covered that in a previous video. And if you want to add something to the mask, click on the player, come down here to the walkable mask, and you can tick multiple of these. So you'll see in the collidable mask, I've actually added ground and default. And in the walkable mask, I've added ground. Now we're not using collidable just yet. We'll come back to that shortly. But for now, let's test this and see if we can drop down off the edges. That's good. Okay, that's not good. That's not what we want. And we should be able to walk off the edge and fall forever. Great. One more test. Gonna walk over here, fall down, good. Fall down, good. Fall down. Great. That looks pretty good. Okay, now we can go down. Let's see about going back up. Okay, for this, we want to check for 3 things. We want to check if we are under something, because obviously we can't move back up if we're under something. We want to check if the height that we're moving against is 1, so we can only step up a height of 1 at a time. And we want to check if the thing we're trying to walk onto is walkable. Alright. So, let's just make a new function here. We're going to call this can move up. I'm going to take a vector 3 direction. That's the direction that we're moving in. So we're just going to cast out a ray here. This one is going to go up. It's going to check if we're underneath something. Now we want to set the collidable mask here. Because if it's not collidable, then we should be able to walk through it. For instance, if you have like a, I don't know, a ghost or something, maybe some shrubs, you can still walk, you know, through them. Or maybe some vines hanging down, something like that. So, we just want to return false if there's anything in the way. Now we want to do pretty much exactly the same thing. I'll just paste this here. But we're going to start from above the player, 1.5 up, because remember the transform of the player is at the bottom. Now the direction that we want to go is not up, but in the direction that we want to move. And everything else is the same. So this is going to check if, well, let's just do a little diagram here. If the player is here and there's a block, what's a good button? Good character for a block like this. There's a block here and you're trying to move up, but there's another block here. So the raycaster is going to hit that block above and say, no, you can't move there, sorry. But if it's empty, it'll be fine. Now the last thing we want to check is if that block we're next to is actually walkable. So we'll just fire another ray straight into it. This is pretty much the same again. I'm going to change this to 0.5 so it's in the center of the player. It's the direction, it's 1, but the mask we're going to use walkable, the walkable mask instead. And now we're going to return true because it's walkable and we're not under a roof and the height is 1. Now we're just going to return false here by default. Cool, that's the function done. Okay, for this part, well, we need to add somewhere to call that function, can move up. So we're going to have to change the way that the player moves. Luckily, we can do this very easily. We're just going to add an else if here. Just add can move up, and then the same direction, vector 3 forward. Now the movement code is almost the same. So I'm just going to paste it here. Now instead of just moving forward, I'm also going to move up. That's it. So I'm going to copy and paste this 3 more times. Change the vectors here to the correct ones. And then we'll go for a test run. Okay, down, up, down, up, good. Down, okay, that's still buggy. We can't walk on top of these. So if I press up, not working. Pressing forward, I'm not going on top of those guys. Okay, that's looking a bit buggy. Definitely don't like the look of that, but let's test this. Okay, we can't go up. It's too high. We can't go up there. Great. Alright. That's all looking pretty fantastic, I'll say. Now let's see what this does. Whoa. Yep, that's not ideal. But we made it out, and now we have levitation powers, it seems. Very cool. So, this particular situation that we have here, I'm not sure if it's a problem for us to fix or if it's more of a level design problem. Why would you have a giant non-walkable block here? I'm not sure. For now I'm just going to leave it. Might fix it in the future. Still levitating. Oh, there we go. Interesting. One thing I do want to test is... Okay. So we can actually come up on here and clip into these diagonal blocks. Again, I don't know, bug or level design problem. Not sure. May fix in the future, but for now, it's probably easiest just to design the level around that. Anyway, there's one thing I do want to fix, and that's when you fall onto one of these. I like it to kind of slide you off. So let's see how we can do that. Alright, let's go underneath this can move up function. We're going to add another function, but this one is a built-in one. We're going to use the on collision enter. Yeah. So this function is built into Unity and it gets called anytime a collider hits another collider. Now in here we want to check if we're falling, because this only happens when we're falling down. We can't move into objects like that. This part is kind of hard to get your head around if you haven't done any layer comparison in Unity. But what this code is doing is just checking the layer of the object that we hit, and then checking if it's inside the walkable mask, if the walkable mask contains this layer, and if it doesn't, returning, well, if it doesn't, then it will return 0, basically. So if we're falling, and if the thing we hit is not walkable, then we want to fire the rest of this logic. So first thing we want to do is set up a direction once again. So vector 3 is 0, we're just going to start off with that. Now, I'm not sure this is the most orthodox way to do this, but I think it's going to work pretty well. So we're just going to set all of the directions here in this little array. Now, we're going to loop through them. No need to do the array length because we know it's just 4. If you add more directions, you can just change the number. It's really not a big deal. So, what we're going to use here is something that we haven't used before, and that's an overlap sphere. Now this is pretty interesting. What it does is it just creates like a circle or a sphere collider at a position for one frame, and then tells you what it collided with. So it'll create a circle or a sphere inside another object if that's where you place it, and it will tell you, oh, I collided with this object. Or, you know, you could make it quite large and it could tell you all of the objects it collided with. So that's pretty cool. And the reason that we're using that is because when you're falling down and you're falling through objects like this, it can get a little bit weird when you're firing rays out. If the origin of the ray is already inside a different object, it won't pick it up. Stuff like that. So this is just a little bit more robust for this particular problem. Now basically what we're doing here is we are looking for any square that's adjacent that doesn't have something in it. And then we're setting the direction to that direction, and then we're breaking. So that means if there's any free squares next to the thing that we fall on, we're going to move straight to there. Well, now we're going to move straight to there when we add this piece of code here. So this is just going to move us on top of the square, and then we're going to fall down. Okay, compiled, good. Alright, so if we fall down onto here, we should just slide off. Yep, just sliding off. It's quite quick. In the future, might add an animation, but now I think it's okay, and that's another level design problem, in my opinion. Might fix it later, but for now, I will just design around this particular issue. So the problem is, if you walk onto this red square here on the left, then this square is blocked because there's a floor underneath me. This square is blocked. This square is blocked. But down here, there's a little space. So it thinks, hey, this is where you're supposed to slide to. And just kind of sticks you in there. I think we're still going to have problems on this large one. Yeah, definitely. That's really unsightly. Whoa. There we go. Alright, so that is going to be wrapping up this episode. Thanks for watching. Catch you.